Hi students, this is section 4.6, multiplying polynomials. So let's get started with our first example here. We have negative 2a squared b cubed times 5ab squared. So how do I know that's multiplication? Because that monomial is right next to that parenthesis. There are no signs, there are no minuses, pluses in between that. So I know we need to multiply. So when we multiply, we're going to multiply the negative 2 times the 5, which will give us negative 10. We have a squared and we have a, right? So if we multiply a squared times a, and for this one, just for this one, I'm going to write it out. A squared times a, right? And then that's b cubed times b squared. So I'm not going to write this out every time, but at least for the first one, I want you to see that you're going to use your rules for exponents, which is when you're multiplying, you have the same base, then you are adding the exponent. So you'll get negative 10 a to the what power? Third power, b to the what power? 5. Because we have a to the first, and 2 plus 1 is 3, and you have 3 plus 2, which is 5. So your final answer is negative 10 a cubed b to the 5th power. All right, let's move on. Let's actually go to the right over here. Notice we have a monomial, but we're multiplying it times 3 different things. Let's start with 2x. So negative 2 times 2, that will give us negative 4. But x times x, again, we add the exponents, 1 plus 1. That's x squared, and we have z squared. Then we're going to multiply negative 2xz squared times negative 3z. So negative times negative, so we know that that's going to be a positive. We'll have a 6. 2 times 3 is 6. X, z cubed, because z squared and z will give us z cubed. Now we need to multiply negative 2xz squared times the last term here, 2z squared, which is negative 4x z to the 4th, since we have z squared times z squared. So that's the final answer for that one. Let's move on to the bottom here. We have a 3a squared. So we're going to multiply that 3a squared times 3a squared first, which would give us a 9a to the 4th, and 3a squared times that negative 5a will give us minus 15a to the 3rd power. Now for our interesting one, there's a fraction involved in this one, so that makes it a little bit more interesting and a little bit more fun. So 4/3 a squared b times 6a. So the main thing is understanding how to multiply fractions. So I'm going to multiply 4/3 over here to the side times 6. So we already know that 6 is understood to be 6 over 1, or 6 divided by 1. And here we could cross cancel, because 3 can divide into 6 2 times, and 3 can divide into itself 1 time. Now we're going to multiply straight across. So 4 times 2 is 8. 8 over 1 equals 8. So we're going to have first, we're going to have an 8. A cubed, since a squared times a is a cubed, and we're going to rewrite our b, minus, since 4/3, this is positive to your left, but we have a minus sign here. Minus, now we have to determine what 4/3 times 5 is. So let's write that out. 4/3 times 5. We know that 5 is the same as 5 divided by 1. But notice here that we can't cross cancel like before. So we must multiply straight across. So 4 times 5 is 20 divided by 3 times 1. All right, is 3. So we have 20 over 3 right here. And when we multiply a squared times that, we get a squared, b times b, b squared. So this is our final answer. Let's move on. Notice that the instructions, I changed the instructions from multiply to find the product. So what does product mean? It means to multiply. So I wanted to switch up the instructions so that you can see that the instructions may be different, but if you understand the meaning of product in math, it simply means to multiply. So get familiar with the terminology that is used in math. Now here we have a binomial times a binomial. So a binomial times a binomial. So we have 2 terms times 2 terms. So notice that since there are 2 terms times 2 terms, you're going to multiply 3x times everything over here. And you're going to turn around and multiply 4 times everything over here. One way that people multiply binomials times binomials is a little acronym they call FOIL. So have you ever heard of FOIL before? It stands for first, which basically means we're going to multiply our first terms together. 3x times 2x is 6x squared. Then we're going to multiply our outer terms together, which is 3x times negative 3. Those are the outside terms, right? Near the outside, 3x and negative 3, which is negative 9x. Then I is for inner, which is 4 times 2x. And you have last terms. The last term of each binomial is 4 and negative 3, which is negative 12. Now you simply simplify. You always simplify in math. So in this case, it means we need to combine like terms. So we're going to combine the negative 9x plus 8x since they are like terms. So that becomes negative x minus 12 since negative 9 plus 8 is negative 1. But of course we don't write the 1 as a coefficient. It's already understood. So let's continue. Let's FOIL. First, 2r times 2r, 4r squared, outer, 2r times t, 2rt, inner, negative 6. So that's negative 3s times 2r, which is negative 6. I'm going to write rs this time. And then negative 3s times t is negative 3st. Now we always need to simplify if possible. But in this case, I don't have any like terms. So we are done with that problem. Let's move on to number 3. Notice that there's a 3 in the front. So maybe I should not have done that. Hopefully that won't be confusing. But this is 3 times 2x minus 3 times x plus 1. What I like to do is simply write down the first number, but multiply the binomials together. So I do the hard part first and I come back for the easy part. So let's FOIL the binomial times binomial. So that's 2x squared plus 2x. Then we multiply negative 3 times x. And we have negative 3 times 1. Now, notice that there are some like terms in here. Let's take care of what's on the inside of the parentheses first. So if we take care of what's on the inside first, let's rewrite 3 times 2x squared. 2x minus 3x are like terms, minus x minus 3. Now let's go back and multiply 3 times everything in the parentheses, which would give us 6x squared minus 3x minus 9. And that is our final answer. Let's move on to number 4, which looks much more complicated than before. So there's a lot going on here. First, this is multiplication. Then we have a minus. Then we're going to have to do some distributing here. So let's break down the problem first by multiplying x plus 1 times x minus 2. So we're going to FOIL, since that is a binomial times a binomial. So that becomes x squared minus 2x plus 1x minus 2. Now here we go with this minus sign here. We're going to distribute this. This is being multiplied times x plus 3. So when we distribute that, that becomes minus 3x squared minus 9x. Now we are going to put our like terms together. We have like terms x squared minus 3x squared. So x squared minus 3x squared is negative 2x squared. Then we have like terms negative 2x plus x minus 9x. So negative 2 plus 1 is negative 1, and minus 9 is negative 10. So minus 10x, and then we're going to simply just write down minus 2 since it doesn't have a like term. Let's move on to the next problem, which are examples of squaring binomials. And here we have x plus 1 squared. What this means, this is a binomial square. This means x plus y times another x plus y. Whenever you see a binomial square, please, pretty please, write it twice. So when there is a binomial square, please write it twice. Then multiply. So we're going to FOIL because this is a binomial times a binomial. X times x is x squared. X times y is xy. Again, we have another xy. Notice I wrote it in alphabetical order. And then y times y is y squared. We are not done because we have like terms in the center. Xy plus xy. How many xy's do we really have? We have x squared plus 2xy plus y squared. So our final answer is x squared plus 2xy plus y squared. If you do it correctly, you're going to have 3 terms in your answer, not 2 terms, which is an error that most students make. They think there is a shortcut to this type of problem, but there is no shortcut. You must write it twice. You must write it twice, okay? When you see a binomial square. All right, so for example, x minus y squared, we are squaring a binomial. So we're going to rewrite it as x minus y times x minus y We're going to FOIL that. It becomes x squared minus xy minus xy plus y squared. Then we have x squared minus 2xy plus y squared. Now, the next problem, we don't have the same sign. We have the opposite sign. So this is up here, we have same sign, notice, because we are squaring the same thing, same sign. But here, notice that we have opposite signs. We're multiplying two binomials. They have the same variable, but with opposite signs. Those are called conjugates. When it basically is this template, we have a plus and you have a minus. Same thing, except the signs are different. So when that happens, something different occurs. So let's multiply this so you can see the difference. X times x is x squared. X times negative y is negative xy. Y times x is xy. Y times negative y is negative y squared. So I want you to see what happens here. This is totally different. Since those signs were opposite, notice that in the center, we have a negative xy plus xy. Notice that those would cancel. All right, so our final answer is simply x squared minus y squared. So notice for that particular problem where you are multiplying conjugates, these are examples of conjugates, you're going to end up with something canceling in the middle, and you're going to only have two terms remaining. Now, let's move on to multiplying what type of polynomial times what type of polynomial. So notice that this is a binomial. And what is this one called? If you said trinomial, you are correct. So what we're going to do, we're going to take our time. Again, we're going to multiply everything in this parenthesis times everything in this parenthesis. Starting with the 3x. So, let's begin. 3x times 2x squared is 6x cubed. What is 3x times negative 4x? Negative 12x squared. Next, 3x times 5. That would be 15x. And again, for more complicated problems, you could stack the terms vertically. For example, now that we have multiplied 3x times everything, let's multiply 2 times everything. 2 times 2x squared is 4x squared. We can put it under its similar term. 2 times negative 4x is negative 8x. So I can write that under 15x. And 2 times 5 would be 10. So it would be by itself. So now you can add everything together. That would be 6x cubed minus 8x squared. 15x minus 8x is a positive 7x. And simply write your 10 down. So your answer is 6x cubed minus 8x squared plus 7x plus 10. Let's try another one like that. Number 2. We have a negative 2x squared plus 3, which is a binomial, times a trinomial. So let's multiply negative 2x squared times 2x squared, which is negative 4x to the 4th power. Negative 2x squared times negative 4x is positive 8x cubed. Negative 2x squared times negative 1 is a positive, because negative times negative is positive, 2x squared. Then we have 3 times 2x squared, which is 6x squared. If you wanted to, you could stack this vertically. 2x squared would go under 2x squared. 6x squared will go under 2x squared. 3 times negative 4x is a negative 12x, so I'll put it over here. And 3 times negative 1 would be negative 3. So our final answer would be negative 4x to the 4th. We're going to also drop the 8x cubed. We're going to add these like terms. So that's 8x squared minus 12x minus 3. All right, lastly, let's solve some equations. Now, for the previous problems, we've been simplifying algebraic expressions. Now that we're solving equations, that's different. How do we know that this is an equation? Well, this example right here. How do we know that that is a equation? Simply put, there is a equal sign in the problem. So when we're solving equations, we are trying to get the variable by itself. But we're going to have to do a little work to this first. So, meaning on the left side it says a minus 3 squared. Now that you understand what that means, I want you to write it down. What does a minus 3 squared mean? What should you do if you see a binomial squared? You should write it twice. I hope you said that. A minus 3 times a minus 3. On the right side here, we have a plus 3 times another a plus 3. And we're going to FOIL this out. We have a squared minus 3a. Inner would be minus 3a again. And last would be plus 9. On the right side of the equal sign, we have a squared plus 3a plus another 3a plus 9. So I'm going to rewrite this, but I'm going to add the like terms. We have like terms in the middle here. So let's rewrite by combining like terms. A squared minus 6a plus 9 equals a squared plus 6a plus 9. Now what we could do right now is try to get like terms together. So for example, you could subtract a squared to try to get it to the left. But what happens? They cancel out. That's awesome. We don't have to deal with the a squareds because they cancel out. So now we simply have negative 6a plus 9 equals 6a plus 9. You could subtract 6a here, right, to get it over here. Notice that these do not cancel because they do not have opposite signs. So what we get is negative 12a plus 9 equals 9. Now what we want is the constants to be on the right side. So we want to get the constants together. So if you subtract 9, what happens is we get negative 12a. This cancels over here. Now I said we cancel this over here, but we need a number and we need to write 0. Yes, it cancels, but in this case, some cases you just have to write the 0. You can't just say, oh, it cancels. You need to write the 0 in some cases. Now we have a negative 12a. How do we get a by itself and detach that negative 12? Well, we need to divide by negative 12 on both sides. Since negative 12 is being multiplied by a, to get rid of the negative 12, we perform the inverse of multiplication, which is division. Therefore, we get a equals 0 as our solution for that particular problem. Let's go to number 2, and I'm doing these specific problems because I want you to really get squaring binomials. When you square binomials, you have to write the binomials twice and FOIL the binomials, okay? You can't simply do some shortcut method and that shortcut method never works, okay? You have to write it twice and FOIL. So for example, we need to write b plus 2 times b plus 2 on the left side of this equal sign, and on the right side we need to write b minus 1 times b minus 1. So let me put a little partition here so we won't get the two problems confused. So we have b squared here plus 2b plus another 2b plus 4. When you multiply all of that together, on the right side we have b squared minus b plus 1. Let's put like terms together. We have b squared plus 4b plus 4 equals b squared negative b minus b. Again, not opposite signs here, so they do not cancel. You get negative 2b plus 1. Now our goal is to get our like terms together and get our variable on one side and everything else on the other side. But notice, let's go ahead and get rid of that b squared. So if I subtract b squared, notice my b squareds go away. Now we simply have 4b plus 4 on the left side and negative 2b plus 1 on the right side. What you could do is try to get that negative 2b on that side, right? But you're going to have to add 2b. You're going to have to add 2b. So add 2b to both sides. That'll cancel it from the right side. But we'll have 6b plus 4 on the left side equals 1. Now I want the 4 to go to the right, so I need to subtract it from the left side. That'll cancel it from the left side, which is what I want because I want to isolate my b, my variable. We get 6b equals negative 3. And how do I solve for b? We divide by 6. That will be 6 divided by 6, which is 1. We say cancel out. So we get b equals negative 3 over 6, which is negative 1/2. So for the first problem, our answer was 0. But for the second problem, our answer was negative 1/2. So that concludes our lesson on 4.6, multiplying polynomials.